we've learned about all different parts of a polynomial function, and all we want to do is we want to put them all together to, if we're given an equation, how we can sort of estimate what the graph is going to look like. So the first thing we wanted to do is we want to determine the end behavior. And that really is a function of the degree, right? If it's even or odd. If it's even, it's going to look like this or this, and if it's odd, it's going to look like this or like this, depending on if A is positive or negative. Okay. I want to find my intercepts. Both my x and my y. Now remember, my x-intercepts are my zeros, and my y-intercept is when x equals 0. Because remember, this is when y is 0. Okay, I want to determine the zeros and the multiplicities. And their multiplicities, because I want to know, is it touching or going through? So that's going to tell me, is it touching or passing through? I want to know the domain and the range. And remember, for our polynomial functions, the domain is always going to be the reals. It's the range is whether it's going to be all reals if it's an odd, or if even function, it'll be a subset of the reals. Then I want to try to sketch a graph of the function. And then determine where it's increasing and decreasing. And then you compare with the graph on the calculator. And from there, if you wanted to, you could find turning points if you want to. You can find the turning points and add them to your graph. So if you do all those things, you'll have a nice graph. And you'll be amazed to see if you actually plot all these points that we found for the zeros and the intercepts and such, and the multiplicities, you'll see it looks pretty close to what the graph should look like.